This video will cover the metric system, the prefixes involved in the metric system, and how we can convert from one set of units to another set of units. So we have a mnemonic device that's a phrase that helps us remember the prefixes of the metric system and the order in which they appear. That phrase is King Henry doesn't bother drinking chocolate milk. The K for king stands for kilo, Henry, hecta, the D for deca, the B for the second D for deci, the C for chocolate is centi, and the M for milk stands for milli. So if we remember King Henry doesn't bother drinking chocolate milk, we remember the order in which these prefixes appear. The big ones are at the top, the little ones are at the bottom. We might look at this basic unit and say, well, what's the basic unit? The basic unit is the unit that stands for the particular thing that we're talking about. So for length, it is meter. For mass, it is grams. And for volume, it is liter. And then these prefixes go in front of them to make them either bigger or smaller. Now you'll notice that in the prefixes that correspond to King Henry doesn't bother drinking chocolate milk, they are all separated by a factor of 10. So if we want to go from basic to deca, there is a difference of 10 in there. If we want to go from deca to hecta, there's a factor of 10 there, and from hecta to kilo, there's a factor of 10 there as well. So if we want to go from, say, basic to kilo, we've got 1 0 here, 2 zeros here, 3 zeros there. So it's basically 1,000. And the rule is there's a lot of little units to one big unit. So the little guy here is basic. So say we're doing meters. 1,000 meters equals one of the bigger units, which are the guys on top, kilometers. So 1,000 meters equals 1 kilometer. That's our conversion factor that we're going to be using. Okay. Now let's try the small ones as well. In the small case, we have let's say we're doing centi, we go from basic to deci, that's a factor of 10. We go from deci to centi, that is a factor of 10. So if we want to say how many centimeters are in a meter, we would have 10 times 10, which is 100. Centimeters equals 1 meter. Remember, centi is a small guy, so it's many of the small guys to one of the big guy. Okay, let's do one more to make sure that we have this down. Let's do basic and milli. We've got 10 to deci, 10 to centi, and 10 to milli. That's 1, 2, 3 zeros. That's 1,000 of the little guys. In this case, milli is the little guys. Millimeter equals 1 of the big guys, 1 meter. Okay? And the cool thing about the metric system is this is true whether we're using meters, liters, or grams. So these same things apply regardless of what the basic unit is. So 1,000 grams equals 1 kilogram. 100 centiliters equals 1 liter. So you can change the basic unit and the numbers all stay the same. Now, King Henry doesn't bother drinking chocolate milk is a great mnemonic for these ones from kilo to milli, and they're all separated by a factor of 10. We do see the ones at the top and the ones at the very bottom. These are additional units that we need to know how to do with conversions. And these guys are separated by a factor of 1,000. So from killi to mega, that's 1,000, or 10 to the third power. And from mega to giga, we have 1,000 more there. So let's do a conversion from basic all the way up to these really big units. Okay, from basic up to kilo, that's 10 times 10 times 10, that's 1,000, or 10 to the third. Then we have a jump of 1,000 to go from kilo to mega. So 10 to the third times 10 to the third, that's 10 to the sixth of the little guys, in this case basic. Let's use grams for this basic one. So 10 to the sixth grams equals 1 of the big guys, megagrams. Okay? 10 to the sixth of the little guys equals 1 of the megas. Then we've got 1,000 more to go to gigas. We're already at 10 to the 6 here, so 3 more zeros would be 10 to the 9th. Add 3 to that exponent. And we have 10 to the 9th gigas, 10 to the 9th grams equals 1 gigagram. Okay? So those are the big guys. You'll notice that giga and mega are both abbreviated by capital letters, capital G and capital M. Those capitals might help you remember that they are on the bigger side. They are the big guys. Now let's look at our smaller units. These smaller units are also separated by a factor of 1,000. So if we have 1,000 going from basic to milli, we have 1,000 more going from milli to micro. 1,000 times 1,000, that's 10 to the 6th. And this time the smaller units are the micro. Now micro, look at this abbreviation for micro. It's the Greek letter mu. And some people think it looks like a U, but it's sort of this unusual looking thing that looks like that. If you can't draw the mu, you could use a U, but do not use an M. M stands for milli, so do not use an M for micro. You can use a U, or if you can draw the mu, that would be preferred. So 10 to the 6th of the little guy, which is the micrometers, would equal 1 meter. Okay. Then we have 1,000 more to jump down to nano. So we add 3 more zeros here. So it's 10 to the 9th nanometers are in 1 meter. And down here we've got 1,000 more to get to pico. So we add 3 more zeros there. So it's 10 to the 12th picometer equaling 1 meter. Okay. So we've got the big guys. We've got King Henry doesn't bother drinking chocolate milk. And we have the little guys. All the ones between King Henry doesn't bother drinking chocolate milk separated by 10. The big and the really little guys separated by 1,000. So you want to be able to convert between any of these different prefixes because we're going to be using those as we go forward. Now you'll notice that this is very different than the way your book presents this topic. The book presents the topic and they have positive exponents and negative exponents, and I find that a lot of students get confused with that. If you do it this way, not only do you have the mnemonic device, but also if you learn that lots of the little guys go into the big guy, all your exponents are always positive. So that when I'm doing problems, that makes it a little easier for me to think about. Now make sure you go back and you work those homework problems, because working these and doing the actual conversions, figuring out how many of what unit is in how many of another unit is the best way to really learn these prefixes.